Imagine a place you visit almost every week, yet never stop to think about how it works. A simple pit stop that keeps millions moving every day. Petrol stations seem mundane, but beneath their familiar surfaces lies 100 years of engineering battles against fire hazards, pollution, and efficiency challenges. Did you know the first petrol stations started with just a single underground tank and a handful of pumps, selling a few gallons a day? Today, they move billions of liters worldwide with near-perfect safety mechanisms that most people don't even notice. The hidden danger of fuel dispensing. Fuel has powered human progress for over a century, but dispensing it safely and efficiently was a challenge from the very start. Gasoline and kerosene are highly flammable liquids that demand careful handling. Imagine the early days when fuel was sold in cans and drivers poured it into their cars with funnels. Slow, messy, and dangerous. The real hazard was not just the liquid itself, but the invisible, flammable vapors that could ignite with the slightest spark. This constant risk made fueling a high-stakes operation long before modern safety standards existed. Beyond safety concerns, early fuel delivery was inefficient and unreliable. Without precise measuring devices, customers had no assurance they were getting the exact amount they paid for. In such conditions, distrust could easily grow, especially as demand rose. Despite these dangers and uncertainties, the growing number of cars meant that making fuel accessible was essential. The desire to address both safety and accuracy planted the seeds for the innovations that would reshape the entire fueling experience. But the biggest obstacles lurked beneath the surface, literally. Storing and transferring flammable liquids underground introduced challenges that would test engineers for decades. The threats of spills, fires, and emissions hovered over every gas station, demanding clever solutions. These risks formed the invisible enemy that every fueling system would have to confront and conquer before stations could become the everyday conveniences we know today. Early innovations in fuel delivery. Before the gas station became a common sight, most homes and businesses used kerosene for lighting and heating, bought directly from stores in cans. The breakthrough came with American inventor Sylvanus Bowser, who created the first practical fuel pump in the late 1800s. His hand-cranked device pumped kerosene through a nozzle, delivering exactly 1 gallon per full turn. This innovation turned fuel dispensing from a slow manual chore into a measured mechanical process that could be standardized. As automobiles gained popularity, Bowser pumps appeared on city streets, manned by attendants who helped fill gas tanks quickly and more safely than before. However, customers still had no way to verify the exact volume dispensed into their cars, leading to potential disputes. This problem was solved a few years later with the invention of the visible fuel pump. Fuel would first be pumped into a glass container atop the pump, allowing the attendant and customer to see the precise amount before letting gravity feed it into the tank below. This transparent method did more than protect customers. It built trust and accelerated gasoline sales. In the early 1900s, there were only a few thousand cars, so these curbside pumps worked well. But as the number of cars started to skyrocket, it became clear that this system wasn't built for volume. The rise of cars created a demand that these early pumps could no longer meet, calling for a fresh approach to fueling infrastructure. Rise of dedicated gas stations. By 1913, the automobile revolution was in full swing. The United States went from about 8,000 cars in 1900 to over 1.2 million just 12 years later. Traffic and demand overwhelmed the small above-ground tanks and single pumps scattered along city streets. Storing fuel above ground not only limited capacity, but also posed serious fire risks. Recognizing these challenges, the Gulf Oil Company broke new ground by opening the first dedicated gas station in Pittsburgh. This station stored kerosene underground in a large tank connected to 6 fueling pumps, allowing several cars to be refueled at once. This design solved 2 critical problems. It increased storage capacity far beyond the old 50-gallon tanks, and it reduced fire hazards by moving combustible fuel below street level. On its first day, it sold only 30 gallons, But just 1 week later, sales jumped to 350 gallons a day at 27 cents per gallon. The success quickly spread, and similar stations sprang up across the country. These larger, safer stations helped turn the car into an instrument of freedom, enabling long-distance travel and reshaping cities and economies. Yet, the story didn't end here. With the shift from kerosene to more volatile gasoline in the 1920s came a new enemy: dangerous vapor emissions. Solving those problems would require a whole new wave of innovation, born from necessity and the pressing demand for safety. Even as storage moved underground, the invisible threat hidden in gasoline vapors continued to challenge both engineers and the public alike. But it's certainly not that challenging to click those like and subscribe buttons for more similar contents. Challenges of gasoline vapor and safety. By the 1920s, gasoline had become the preferred fuel over kerosene because it burned more efficiently and powered cars better. But switching to gasoline introduced a hidden danger. Its extremely low flash point meant it constantly released flammable vapors into the air. Unlike kerosene, which only emitted vapor at higher temperatures, gasoline's vapor was present even at cold temperatures. This created a persistent fire hazard around gas stations, especially when filling a car's tank. A single spark could ignite those vapors, turning a routine pit stop into a deadly accident. The problem wasn't just fire risk. These gasoline vapors also polluted the air, adding to early environmental worries. As the fuel tanks stored gasoline underground, vapors would build up inside them. When a delivery truck refilled these tanks, the displaced vapors had nowhere to go but into the atmosphere, releasing harmful and flammable gases outside. On top of this, the steel underground tanks corroded over time, leading to leaks that contaminated the soil. These overlapping dangers meant that engineers had to rethink how to design every part of a gas station. Cleaning up the mess wasn't simple. Gas stations couldn't just operate like they had before without risking explosions or environmental damage. The technology to capture vapors, prevent corrosion, and safely store fuel underground had to evolve quickly to meet booming car ownership and public safety demands. With these dangers pressing, engineers began devising inventions that would change gas stations from perilous sites into safe, reliable places for fueling. Engineering breakthroughs for safety and efficiency. One of the first game changers was the automatic shutoff valve. Previously, attendants manually controlled fuel flow, and customers had no way to know when their tanks were full, leading to frequent spills and hazards. This valve used a mechanical float inside the nozzle, which rose with the fuel level and automatically stopped the flow once the tank was full. This simple invention made self-service fueling safer and helped reduce costly spills that could ignite or pollute the station. Meanwhile, the underground steel tanks were being replaced due to corrosion concerns. Fiberglass tanks came into use because they resist rust and last much longer underground without leaking. Engineers also added multiple safety features inside these tanks. For example, a flapper valve shuts off incoming fuel when the tank is 95% full, preventing dangerous overfills. Additionally, vapor recovery systems were introduced so that when a delivery truck pumped fuel into the tank, vapors were pushed back through a sealed valve into the tanker truck rather than escaping into the air. This vapor was then returned to the refinery, condensed back into liquid fuel, and reused. Together, these breakthroughs turned gas stations from hazardous fire traps into efficient, environmentally safer service points. Innovations deep underground, combined with smarter nozzles and pumps above ground, created a system that's both reliable and surprisingly complex. The final piece of this intricate puzzle lies in the fuel nozzle itself, a deceptively simple device that conceals advanced safety engineering. Modern fuel nozzle mechanics. At first glance, a fuel nozzle looks like a simple tap releasing gasoline into a car. But behind this unassuming device lies one of the most clever safety mechanisms in petrol station engineering. When you pull the lever, fuel flows through a narrow opening, speeding up and creating a low-pressure area due to the Venturi effect. This low pressure sucks in air through tiny holes around the nozzle's tip, mixing air with the fuel inside a small chamber. This mixture and airflow are key to how the nozzle knows when to stop delivering fuel. Inside that chamber sits a sealed membrane held in place by tiny ball bearings. Pressing the lever opens a valve allowing fuel to pass through and fill your tank. But when your tank fills, gasoline covers the hole at the nozzle's tip, stopping air from entering. With no air coming in, a vacuum forms in the chamber, lifting the membrane and releasing the ball bearings. This lets the levers snap back, instantly cutting off the fuel flow. It's a simple mechanical failsafe that prevents overfilling and dangerous spills without any electronics. This design evolved over decades of trial and error to solve the risks of spills, fires, and wasted fuel. Combined with underground storage innovations and vapor recovery, the nozzle's precision completes a complex system working invisibly every time you fill up. From early hand pumps to today's high-tech nozzles, petrol stations have transformed through relentless innovation to become safe and efficient. Understanding these hidden mechanics gives us a new appreciation for a place we often take for granted. If you enjoyed uncovering the secrets behind everyday engineering, please like this video and subscribe for more fascinating stories. Thanks for watching, and I'll see you in the next one.